To all of you. So today I'll be discussing 9709 Cambridge International AS A-Level Maths paper. This is a pure Maths paper 1 and this is 9709/12 May-June 2021 paper. So I've got a request from many of my students regarding question 12. They want me to discuss question 12 with them. So this question is basically regarding a cylindrical pipe and getting its circumference, getting its area. So due to the request of my students, I'm making this video. So I hope you all enjoy it. And if you have any questions, you can certainly put in the chat box. All right. So let me share the question now, all of you. Okay. So let's look at the question 12 here. So I hope you guys can see the question. So they say the diagram shows a cross section of 7 cylindrical pipes, each of radius 20 cm. That means you have basically in this hexagon here, within this hexagon shape here, you can see that inside the hexagonal shape, there's 7 cylindrical pipes and each pipe has a radius of 20 cm, held together by a thin rope which is wrapped tightly around the pipes. So around the middle pipe, okay, which is a circle. Now all of them are evenly sized because they share the same radius of 20 cm. But around the middle pipe, you've got 6 other pipes which is placed outside, and within the 6 pipes, okay, from the 6 pipes which is placed outside, there's a thin rope which is tightly wrapped around these pipes. So they say the center of these 6 outer pipes A, B, C, D, E, F. Alright, these are the centers of these 6 outer pipes. Now, what are P and Q? Points P and Q are situated where straight sections of the rope meets the pipe with the center A. So basically, if you want to really, see the length of the thin rope which is wrapped outside the pipes, then it's basically covered by straight length as well as the curved length. All right. So what are the straight section as well as the curved section? We will have a look at it, as we are progressing in the question. Okay. So let's look at question A now. They're saying show the angle PAQ is equals to 1/3 pi radian. All right, 1/3 pi radian. To combine all of these 6, okay, so let me just draw this. Let me just do a rough sketch of this drawing here. Okay, so I hope I can, I can draw this well. All right, so okay, so if you see here, what happens is that they're asking us if this is A, right? They want us to get PAQ here. So if you notice, we have got 6 points here. We have got B, C, D, E, and F. Okay, so now what happens is that we can basically say if you were to combine all of these 6 points together, you get a complete circle. Okay, if you were to combine all of the 6 points together, you get a complete circle. So here we can say basically 6 multiply PAQ. All right, so I'm going to put this here. PAQ is actually basically equals to 2 pi. All right, so in order to get PAQ, it's basically 2 pi over 6. So therefore PAQ is basically pi over 3. So because they ask us to show, so we say pi over 3 radian and show. Remember, I told you guys, whenever you have any questions regarding shown, you have to write there shown. So you're basically telling the examiner you know what is the question and you have answered the question and you've written there shown. All right, so this is part A. Okay, so I hope you guys got it for part A. Now let's go to part B. So find the length of the rope. So find the length of the rope. This is what we're going to look at here. So let me just erase this. So we're going to part B. So let me just draw this again. So please excuse me. So sorry for my drawings here. So maybe I can draw the hexagonal shape here first. Okay, so we have got 6 Okay, so what happens is that there's few things that we have to take note. All right, so here we have got these points. Okay, this is going to be your outer points A, B, C, D, and F. Okay, so let's label them A, B, C, D, E, and F. All right, okay, so these are the circles. And then what we're going to do is we're basically going to connect all these points together. Okay, so when we connect, then what you get is a hexagon. All right, next what we're going to do is we're basically going to draw what you call a rectangle. Now let me show you what I mean by a rectangle. Okay, so here when I say rectangle are basically what you call this section here. These are your rectangles. These are your rectangles. This is what we are looking at. Okay, so if you guys can see, you have basically got 6 rectangles there. All right, so this is what we're looking at. So in order to get the question here says to find the length of the rope, that basically means you have to get the straight sections here. So the straight sections here would basically be this one here, this one here, 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 and here. And the curved sections will be this one here, the arc length. Okay, you have got your curved, so you have got 6 curved sections here. Okay, so what we're going to do now is we're basically going to rewrite them. Maybe I can relabel my points here so it's clearer. Can label them A, B, C, D, E, and F. So I can write it down as straight section. So the length, okay, the length of straight section, here is basically AF plus FE plus ED plus DC plus CD plus BA. All right, so then it's basically, you know, getting the length of the straight sections here. So getting the length of the straight sections here is basically, if you see, it's 2 times the radius, because, you know, from A to here, let's say I'm looking at this part here, this is basically half of a radius. Okay, so that's basically 20 that is basically a radius, so that would be 20 cm, and then from this point to F, that would be another 20 cm. So we're going to say 2 times 20. All right, so you get 40, and you have got 6 sections here, so we're going to times by 6, so you get 240 cm. All right, so the total, this is the length of each section. So if you want to get the total length of 6 sections, that would basically be 240 cm. So this is the first part that we have got here. So I hope you guys understand. We have got basically 6 straight sections here. All right, AF, like I've written there, AF, FE, ED, DC, CB, and BA. So all of it, they are basically 6 sections. So we multiply by 6. Each section, the length is 40 cm. So we get 240 here. All right, so now looking at the next one here. Okay, so we're going to look at the curved section now. So we have got 6 curved sections. So curved sections is basically calculating using the formula S equals to R theta, which is getting the length, the arc length. Okay, so maybe we can write it down here. Curved section. Okay, so curved section here will basically be R theta, which is 20 times, we know that your theta is pi over 3. We have shown that in part A. So we get here 20 pi over 3. So this would be the curved section. Now, curved section, we have only calculated one curved section. So if you want to get the total of all 6 curved sections, that would be total curved sections. I'm just going to put it as SC. So that would basically be 6 times 20 pi over 3. So that would be, when you multiply, when you cancel off, you're going to get 40 pi. Okay, what we're going to do now is we're going to get the total length. So the total length basically will be total length of will be equals to the total straight length plus the total curved length, right? So here total length will be total straight length plus total curved length, right? Total curved length. So here earlier on we got the straight length is 240 plus earlier on we have calculated the curved length, that would basically be 40 pi. So we get this to be 240 pi, and if you were to press the calculator, you get about 365.66 cm. So if you were to round it up, you can write it down as 366 cm, and this would be the final answer for part B. Alright, so this is the answer for part B. Now they're asking you, in part C, the question says, find the area of the hexagon ABCDEF, giving your answers in terms of pi cert 3. Alright, so giving your answers in terms of cert 3. Now in order to get the area of the hexagon, there's actually a hint here. We can get the area of the triangle. Okay, now how do we get the area of the triangle? So what we can do is, in part C, if you notice, if you were to connect all the centers of the circles, the 6 circles, the 6 outer pipes, the A, B, C, D, E, F, you basically get a hexagon, right? So if you were to connect them, if you were to draw them, okay, then you get this to be your A, B, C, D, E, and F. And you have your middle circle here, so that would be the center of the middle circle. So if you were to combine, okay, if you were to construct, you basically get 6 triangles here. So let's say we are looking into one of the triangles. Let's say I label this as O, okay, the middle circle center to be O. So now we are looking at this triangle here. Okay, so then we know that your radius is basically, when you're looking at it, it will basically be 40. Okay, this length will be 40 because it's a combination of 2 centers, 2 circles radius. This will be 40. This also will be 40, and when you look at the angle here, it will be pi over 3 because we have calculated earlier on. They have actually mentioned it to us that it's basically pi over 3. So here, therefore, we can use this to be, you can use the angle to be pi over 3, and we can calculate, let's say, if you're looking into the triangle, okay, and triangle area of triangle EOD, alright, so that would basically be half times 40 times 40 times sine pi over 3. So here, if you were to press the calculator, you get 800 cert 3 over 2. Okay, you get this as your answer. And later on, when you simplify, you can leave it as 400 cert 3. Now, we are not going to be, pressing the calculator and dissolving them into decimal places because the question has requested us to keep our answers in terms of cert 3. So we're going to leave it as such. Okay, now this is only the area of one triangle, but remember, as I've drawn, I've shown you guys that in this whole hexagon shape, you basically get 6 triangles. So that means in order to get the area of the hexagon, you just have to multiply 6 to one of these areas. Alright, so to get the area, right, so area of hexagon will be 6 times 400 cert 3, and you get 2400 cert 3 cm squared. So that would be your answer. Alright, so it's best to leave your answers in Cert 3 because they've requested us to give you answers in Cert 3, right? Okay, so the next one, the question says that they're asking us to find the area of the complete region enclosed by the rope. Okay, so area of the complete region enclosed by the rope, that means we have actually calculated the area of the hexagon. Now all we have to do is to calculate the rectangles that I've drawn earlier on. I think in this when I was discussing question B and A, I've drawn for you the shape. So we have got the green rectangles, so we'll have to calculate the rectangles as well as the curved section. So that would be, right? So looking at question B, okay, so what we're going to do now is we're going to first find area of each rectangle. Okay, rectangle. So we get 40 multiplied by 20. Okay, that's the dimension of the rectangle. So you get 800 cm square. And area of each sector. So we have each circle sector here. So we're going to calculate that. That would be half r square theta. So we get half. R is 20. The radius is 20 times your theta is pi over 3. So remember, when you're using pi over 3, your calculator has to be in the radian mode, not degree mode. Alright, so please be aware of that. So here you get times 400 times pi over 3. And if you were to cancel this, you get 200 pi over 3. Okay, so this is basically the area of each rectangle, area of each sector. Now we're going to get the area of the total region enclosed by the rope. So if I draw this for you, you have basically got your, this is your hexagon. All right, so you had your rectangles here. These were the rectangles that we were drawing. And then we had another rectangle here, one rectangle here, another rectangle here, another rectangle here. So these were the 6 rectangles. And if you were to look at the curved area, this were the curved area. So this is the area of each sector. And all of this, when you add them up, you get the total area, total region enclosed by the rope. Okay, so we have got the area of the hexagon now. We have calculated the area of the rectangles, all of this which is outside, and then we have calculated all the curved sector. All right, the ones that I'm shading now, we have calculated this using half r square theta. Okay, so what we're going to do is we're going to add them up together. So here we say total area of region would be equals to 6 times area of rectangle plus 6 times area of sector plus area of hexagon. Okay, so here what we're going to do, we're going to substitute the values in. So earlier on, area of rectangle, we found that it's 800 plus the area of sector, we managed to find it was actually 200 over 3 pi, and our area of hexagon is 2400 square root 3. So if you were to add all of this up, this is 4800, and if you were to open these brackets, you get 400 pi plus 2400 square root 3. So you get this as your answer. And if you were to press the calculator and dissolve the value, you get 10213.559. So if you want to write it down, you get 10214 cm square. So this is the total area of the region. All right, so I hope this has answered all your questions. So if you have any comments, you can always message me and I'll get back to you. Thank you. Bye bye.